Hello once again. Now in this session, in continuation to earlier session, we'll talk about now another object file format, mostly known as Windows Portable Executable Format, PE format. Now this format is standard file format for an executable files, object codes as well as DLLs in Windows operating systems. It is used by both 32-bit and 64-bit versions of Windows and serves as a foundation for applications and system programs. This format is derived from MS-DOS exe format, but is much more complex, designed to support advanced features like virtual memory, dynamic linking, support to multiple architectures, and so on. So, like features perspective, of the PE format, following are the four features that generally can be found into PE format. One most important thing is portable. This PE format is designed to be portable across different versions of Windows. It can run on various hardware platforms. It could be x86, x64, or maybe ARM without modification. And that makes it unique, at least for Windows. Executable, second feature. These PE files have executable programs that can be run by Windows operating system. Third feature is extensible, it supports different sections like code, data, resources, and allows extensions such as like you can add a dynamic linking for DLLs too. And as I stated earlier, the fourth feature is it supports 32-bit and 64-bit because P format is having like some internal differences based on the target architecture. So it verifies whether what architecture you are running it on, and then it will tell you about it, like whether we can it execute or not. So this would be mostly through the stub, which we earlier even talked about. That stub code checks whether this program is meant for Windows platform or not. Now let us try to understand the structure of Windows PE file. Like earlier file formats, this format also is divided into several components, or you just can call it as headers, which provides information about how to load, execute, and manage the file in memory. So like one can see there are 10 different components. Let us start with DOS header. As we talked earlier, even with the exe file format, this is a legacy header which is inherited from the old MS-DOS executable format. And it ensures backward compatibility of with MS-DOS. Even this contains MZ as a magic number, like shown with respect using 2 bytes. Say, for example, for M it is 0x4D, and for Z it is 0x5A. And this header or this magic number points to PE header. Like the structure of this DOS header contains two things, as I stated. E magic is one variable, which is a 2 byte MZ signature, and ELF NU, which is a pointer to P header, which starts with P uh, /0 /0. When P file is running on Windows, the DOS header is ignored and the P header is processed. Now, if you are running this file on Windows DOS, then DOS header would be appropriately there used internally. Now, second element from the structure perspective is P header, generally called as P signature. As I stated earlier, P /0 /0 / located right after the DOS header, which indicates starting point of the portable executable format. This is a 4 byte value. So which is exactly like if you really check it on through the different tools available on Windows. The 4-byte value is 0x 4 zeros consecutively, and lastly 4550, which is an exact translation, hex translation of that P/0/0. This is where the loader looks to identify beginning of your executable sections. And this differentiates it from the older exe format. The third important component is COF, which is a COF file header. Like this is common object file format header, and it describes architecture, it describes file type, and other basic properties of your PE file. Now, if we have to talk about this COF, then it will have information about a machine, like which talks about CPU, target CPU architecture. Even it will store information about number of sections. Then there will be a timestamp when the file is created. There would be a pointer added in this COF file header, which is a pointer for a symbol table, which points to the symbol table of your file. It also holds information about number of symbols. Further, like it will contain size of optional header. Now, this optional header uh, is there, which contains more detailed information from for the executable files. And it also can contain characteristics like the flags, which are indicating the file type. For example, whether it is a executable, DLL, or system file. The fourth is optional header. Despite its name, like when we say it is given name as optional header, but this section is mandatory for executable files. It provides critical information about program's memory layout. Even it holds information about entry point and much more thing. From the structure perspective, it has a structure like this optional header also has a structure which has like some few elements which we will be addressing now. There is something called as magic. This identifies a magic number. This identifies that P file is either a 32-bit or a 64-bit. There would be major and minor linkable version. These version numbers would be used for the linker that built this file, the PE file. It will contain size of code, data, and BSS. It also will contain a virtual address, that is entry point, where the execution begins. It also will have base addresses for your code, your data, even the preferred load address of the image, like your executable image, where the file should be ideally loaded in memory, would be added there. Now, as we know that section alignment is required, so the alignment also would be added for sections in memory. Generally, typically it is of 4 KB size. Even the alignment of the file also is needed for the sections in the file on the disk. Further, as an important element, it contains information about your OS version, the minimum required operating system version for the file to run. Then next element is section table. This section table contains details about individual sections. Like we know them, like code, data, and if at all resources required. There are some common sections too, like generally seen the dot text, dot data, dot oro data, dot bss. Even like if it is meant for Windows, then it would be having a section called dot rsrc, like which contains resources like icons, bitmaps, dialog boxes, strings, etc. The sixth element is section data. After the section table, the actual data for each section is added, which includes executable instruction of code, which is added in code, initialize data from the data section, data and resources like icons, menus, strings. Even these sections data is loaded at a specified virtual address due to this section data. Further, it has information about import table. This import table is used to list the external functions, if at all you are referring to, or even like it's not only about external functions, but they can be symbols too, which are needed from other dynamic libraries, the dynamic link libraries, DLLs. Now, the loader uses this table, import table, to resolve external function calls when the function program starts. And that's why it is very, very important, because we know that API calls are done through these DLLs. The eighth one is export table. Again, like this is optional. If your P file is a dynamic link library or a shared library, then export table contains list of all functions that the DLL provides for use by the other programs. If some other program is trying to export it, then it would be getting very easily information about all such functions added into that DLL. By like it also provides information about addresses of those functions, even the variables which would be available for external programs to call. And that is one important feature of this kind of file. Then ninth one is relocation table. This was like when meant for relocation purposes only. If your program is loaded into memory location other than the preferred base address, then only this relocation table is used, so as to address your to adjust the addresses of your data and code. And lastly, the debug data. Now again, like this is optional. If your executable is built with debugging information, then this section contains data used by the debuggers. For example, like we know while we debug, we would be requiring names of the functions, we would requiring variable names, even we will require line numbers. So these all are elements of your Windows PE file. Now, when this P gets executed, what happens is it follows these steps for a while. Load the file, like your Windows loader reads that PE file starting with the DOS header to check this MS signature. Then after MS signature is verified, your loader would be loading the PE header followed by COF header and optional headers. Then if your program needs relocation, the loader adjusts addresses according to the relocation table. Once relocation is done, it has to map the sections into memory based on the information added into section table. Then if some import is done, the loader will try to resolve any external function call by loading required DLLs and link them to your program. Then loader transfers control to the entry point defined in the PE header, beginning with the program, which begins the program execution. Now the program runs, executes its code, performs IO, and interacts with the system resources. And once the program execution is done, program terminates by calling an exit function. Or maybe like if it doesn't give a call to exit function, then it reaches to the end of execution. So like if we have to really see again in broader details, like one can say starting this P executable process is relatively straightforward. Like as we stated earlier, it will read in the first page of the file with DOS header, P header, and optional headers or section headers. Determine whether the target area of the address space is available or not. If not, then allocate another area, because of like this can be done or achieved through relocation. Now using this information, in the section headers, it will map all the sections to the file at the appropriate place in the allocated address space. And if file is not loaded into target addresses, it applies fixups. It goes through the list of DLLs in the import section and load any that aren't already loaded. And this process may be recursive, as we stated in earlier case. Then it resolves all important symbols in the import section, create initial stack and heap using values from the PE header, creates initial thread and start the process. And this is how your executable would be executable. This is what about this Windows PE format.